Good learners, you are welcome back to my channel Aliphatic Teaches. Today, we want to continue on our predicted WAEC questions, which I promise if you go by this and study them very well, you will never miss a question without getting them. So, quantitative analysis is what we are still treating. I remain Latif Ismaila Akambi, your mathematics and chemistry tutor. If you are a new member on this channel, kindly subscribe to my channel and click the notification bell for my subsequent content. And don't forget to share, like, and leave a comment as we move on. So, let's move on. Question 2. A is 0.1 mole per dm cube of HCl. B is a solution containing 18 grams of impure sodium hydrogen triisocarbonate 4 per dm cube. A. Put A into the burette and titrate it against 25 centimeter cube portions of B using methyl orange as the indicator. As I explained in my first video, in your school, you might be given 20 centimeter cube of the pipette. Why? You might be given 25. So why will give you 20 or 25 centimeter cube. So you pick the one you are using in your school. If in your school it is 20 centimeter cube, you pick 20 centimeter cube as the volume of your pipette. If it is 25, you pick 25 as the volume of your own pipette. That's the volume of your base. Let's continue. Repeat the titration to obtain consistent titers. Tabulate your burette readings and calculate the average volume of acid used. The equation for the reaction is HCl plus sodium hydrogen carbonate to give sodium chloride, water, and carbon dioxide. This equation is balanced already, and the ratio of acid to base is 1:1. Question B. From your results and the information provided above, calculate the figure 1 concentration of B in mole per dm cube. Figure 2 mass of sodium hydrogen carbonate per dm cube of solution B. Figure 3 percentage purity of sodium hydrogen carbonate. Figure 4 percentage impurity of sodium hydrogen carbonate. This has been assumed you have done your titration and you've gotten your average volume of acid used. Let's assume it is 24.60. So we're going to be using the volume of acid used as being said here. Repeat the titration to obtain consistent titers. Calculate your burette readings and calculate the average volume of acid used. So we have done that and we got our average volume of acid used as 24.60. Fine. Then let us now move on with this calculation. Let's start to calculate this one after the other. Now let's proceed. HCl plus sodium hydrogen carbonate to give sodium chloride, water, and carbon dioxide according to the equation given to us. So we have 1:1, 1:1. Now, let's go back to the question. A is 0.1 mole per dm cube of acid. That is HCl. Anything in mole per dm cube, we know it means concentration. So concentration of acid is equal to 0.1 mole per dm cube. We are told that it contains 18 grams of impure sodium hydrogen carbonate per dm cube. Now, this 18 grams of sodium hydrogen carbonate per dm cube means that it has been standardized already. But it is not the mass concentration of sodium hydrogen carbonate because it is impure, meaning that it contains some impurity. So mass of impure sodium hydrogen triisocarbonate 4 is 18 grams per dm cube. Fine. Next one is now, how do we now calculate the first one? The concentration of sodium hydrogen carbonate 4 in solution B. in what? In mole per dm cube. Now, we are given concentration of the acid, Ca already. Don't forget, the concentration of base is what we want to find, and also the volume of the acid we assume that to be 24.60 centimeter cube. Then the volume of base, in my own, I'm using 25 centimeter cube. Now, the number of acid here is equals to 1, while the number of base also equals to 1. Now, given this parameter, we have Ca, we're looking for Cb. We have Va, we have Vb, Na, and Nb. Everything we can use the formula that says Ca, Va over Cb, Vb equals to Na over what? Mb. So, given this formula now, I want to calculate my Cb. I have to cross multiply so that the unknown will come to the left. This will come and meet this. This will come and meet this. We have Cb, Vb, Na is equals to Ca, Va, Mb. Now I want to get my Cb. So Cb equals to, so you divide both sides by Vb and Na. So I have Ca, Va, Mb divided by Vb and Na. Vb and Na. So what's our question of the acid? We have 0.1 multiplied by volume of acid. We have 24.60. Number of base is 1. Volume of beta we use 25 times 1. So we multiply 0.1 times 24.60 times 1. So we have 2.46 divided by 25. We have 0.0984. Now, question of the base. And our answer must be to 3 significant figures. So these zeros are non-significant, so we count 1, 2, 3. So it's complete 3 already. So unit is mole per dm cube. Now, the second question is to find the mass of sodium hydrogen carbonate per dm cube in solution B. What they are actually telling us to find is to find the mass concentration of sodium hydrogen carbonate. Now, since we have gotten our Cb, then how do we now get the mass concentration in gram per dm cube? Don't forget the second formula that we normally use that says molar concentration in mole per dm cube is equal to mass concentration in gram per dm cube over molar mass in gram per mole. So we need our mass concentration. So let's cross multiply. This comes out. Mass concentration in gram per dm cube equals to molar concentration in mole per dm cube times molar mass. Now we know our molar concentration we've gotten from here. Then our molar mass, let's find the molar mass of sodium hydrogen carbonate. To get the molar mass of sodium hydrogen carbonate, we have to sum up the atomic masses of each of the elements. Atomic mass of sodium, don't forget, it will be given to you in a bracket in the question. Sodium is 23, hydrogen is 1, carbon is 12, then our oxygen 16 multiplied by 3. So we have 23 plus 1, we have 24. 24 plus 12, we have 36. 36 plus 60 times 3, 48. So when you sum it up, we have 84 grams per mole. So from here now, we can now apply our values into this equation. Mass concentration in gram per dm cube now is equal to molar concentration, which is 0.0984 multiplied by molar mass that we got, 84. So when we multiply, what do we have? 8.2656. And this should be to 3 significant figures. 1, 2, 3. So this is a third digit. You look at the back of it, which is 5. Any number from 5 to 9, you round up to 1. But from 1 to 4, round down to 0. So this one becomes 1. Add the 1 to this is making 7. So we have 8.27 in what? Gram per dm cube. So the third question is to find the percentage purity of sodium hydrogen carbonate. So we use this formula. Percentage purity is equals to mass concentration of pure over mass concentration of impure multiplied by 100 over 1. And don't forget, we're talking about percentage purity of sodium hydrogen carbonate. We have gotten the mass concentration of percentage purity of sodium hydrogen carbonate to be 8.27. Then mass concentration of impure, we have been given that 18 gram of impure sodium hydrogen carbonate per dm cube we have been given. So here we now have mass concentration of sodium hydrogen carbonate is 8.27 divided by 18 multiplied by 100 over 1. So we have 8.27 times 100 divided by 18. So we multiply this and divide by 18. We have 45.9444 and so on like that. So our answer should be to 3 significant figures. 1, 2, 3. At the back of the third digit, we have 4. Any number from 1 to 4, you round down to 0. So we have 45.9. So percentage purity, that is percent. The last question, which is question Roman figure 4, is to find the percentage impurity of sodium hydrogen carbonate. So we know that percentage purity plus percentage impurity, total percentage is 100. So percentage purity plus percentage impurity should be equals to 100. And we have gotten the percentage purity here to be 45.9 plus percentage impurity, let's call it x, equals to 100. Cross multiply, x will equals to 100 minus 45.9. So s equals to, so we take it away. So we have 54.1%. So the percentage impurity of sodium hydrogen carbonate is this. So the percentage impurity of sodium hydrogen carbonate is equals to 54.1%. So when you sum these 54.1 and sum it up with 45.9, you are going to get it to be what? 100. So this is the second question in our predicted question of WAEC Practical 2025. Don't forget to subscribe to my channel, Aliphatic Teaches, and click the notification bell for my subsequent content. And don't forget also to share, like, and leave a comment as we leave the channel. I will see you in the third lesson where we'll be treating the third question. Thank you very much.